The surface of Antarctica is a sensory vacuum. No birds, no plants, and only a few centimeters of annual snowfall make this the coldest, driest desert on Earth. In 1970, a Soviet team at Vostok Station began a drilling project that would span nearly 3 decades. They ground through the ice layer by layer, eventually reaching a depth of nearly 4,000 meters. They stopped just short of the bedrock when the drill hit something unexpected. Beneath thousands of meters of solid ice, they found liquid water. They had discovered Lake Vostok, a body of water the size of Lake Ontario that has been sealed off from the Earth's atmosphere for 15 million years. The discovery proved that an aquatic environment exists in total darkness, surviving under the weight of a 2-mile-thick ice sheet. Mapping the rest of the continent required more than just drilling. Researchers began using space lasers and ice-penetrating radar mounted on planes to see through the wide expanse. The radar revealed a hidden topography of massive proportions. Beneath the ice lies a trench deeper than the Grand Canyon and a mountain range rivaling the European Alps. Satellite data added another layer to the mystery, showing the ice sheet lifting and dropping by 10 meters. The continent appeared to be breathing. This movement is caused by an active plumbing system. Hundreds of subglacial lakes sit beneath the surface, connected by rivers that fill and drain as the water moves across the bedrock. Antarctica behaves as a dynamic, interconnected system, housing a hidden world that follows its own geological rules. Keeping water liquid in a polar wasteland requires 2 physical anchors. First, the massive ice sheet acts as a thermal blanket, trapping the geothermal heat radiating from the Earth's core. The second factor is pressure. The ice's weight creates force 350 times greater than sea level, lowering the water's freezing point. But this makes drilling hazardous. Puncturing the lake can trigger a blowout, sending an explosive geyser up the drill shaft. Researchers compare the risk to dropping a mint into a sealed, pressurized bottle of soda and suddenly removing the cap. Reaching this water is a high-stakes gamble. Every centimeter deeper increases the risk of a catastrophic release that could destroy the equipment and the camp above. Drilling is a slow vertical journey through time. The rig recovers ice containing tiny bubbles of atmosphere locked in the core from the exact moment they froze. This core acts as a historical record. Researchers can pull up and analyze the exact air humans breathed during the height of the Roman Empire. Further down, the ice records the era of the first modern humans and the extinction of the Neanderthals. Major geological events leave physical markers. This core contains a distinct band of ash from a volcanic eruption that occurred 20,000 years ago. These cores provide a climate history that stretches back over 1 million years, offering a physical record of the planet's atmosphere before reaching the lakes at the bottom. By the 2010s, an international race was underway to sample a subglacial lake. The Russian team, the British team, and the American team each attempted to reach the water without contaminating the environment. The Russian team at Lake Vostok faced a major setback when their drilling fluid, a mixture of kerosene and freon, mixed with the lake water during a blowout, contaminating their sample. A British team attempted to reach Lake Ellsworth using a hot water drill, but they ran out of fuel just short of the lake, forcing them to abandon the project. The American team at Lake Whillans used a different strategy, a custom rig that blasted UV-purified, boiling water to melt through the ice while keeping the environment sterile. This approach represented the final attempt to observe an ancient, isolated ecosystem without introducing modern bacteria or chemicals. The American team successfully breached the lake and recovered pristine liquid water and sediment from the basin. The samples revealed a dense, thriving ecosystem. Colonies of bacteria and specialized viruses were found swimming and multiplying in the darkness. This biological community has been isolated for millions of years, evolving and thriving without ever being exposed to sunlight. The organisms have adapted to the highest pressures on the planet, surviving in a cold, dark environment that was once thought to be sterile. Antarctica's extreme depths serve as a cradle for biological adaptation, proving that life can persist even in the most hostile conditions on Earth. These discoveries shift the focus of exploration from our own history to the search for life beyond Earth. The subglacial lakes of Antarctica provide a physical analog for the icy oceans hidden beneath the frozen crusts of moons like Europa. The sterilized drilling technology and biological data collected here provide a framework for future missions to identify organisms in our solar system. On our own planet, hundreds of these underground lakes remain unexplored, each holding its own potential for discovery. Reaching into these isolated depths provides the methodology needed to find life among the stars. Subscribe for more hidden truths.